Hello, in this video we are going to go over some conditionals. Let's get to it. If you're new here, don't forget to like, share, and subscribe below, and you can get a lot of cool content just like this. So here's another important fundamentals, and those are called conditionals. And let me tell you what a conditional is. Essentially what a conditional is that you're able to run some sort of logic depending on if a condition is met or not. Or if you have multiple types of conditions, you can run logic based on if it meets one of those conditions. So let's go into the different types of conditionals there are. And with these different kinds of conditionals, they really depend on language to language. But in most cases, there's always some sort of a version of it inside of each of these programming language. And they all work pretty much the same. You can all use them interchangeably. So there's not a preference or a performance. Depending on which one you choose, they all do the exact same thing. It's just different ways of doing it. And I would get used to what they are and how they are used. And then you can see which one that you like the most and start using the ones that you do like the most. Because again, these are all almost the exact same way of doing things. They just are a little bit different. And over here, these aren't technically conditionals. They're what you can use inside of conditionals. And we'll see how those work. Those are just keywords that will aid or help you with the conditionals here. So before we go into a conditional, we need to talk about the individual conditions in them. And we talked about this a little bit inside of our comparators video. If you haven't seen that, go ahead and click on this card right here for you to check that video out. So essentially with our conditionals, we need to have our items written as a certain point. The first thing is that it must return true to run for most cases of this. So with these individual statements, if it returns true, then it will run the logic or whatever you need it to run. And when we are also having our conditions, it needs to not be tautological, not always true. And what that means is that when we create our conditions, it can't always be true or it can't always be false, which is not contradiction. It has to be either way true or either way false in some shape or form. But for some of the conditions to be met, then one of those conditions needs to be true. So if it's always true, then that means that they all run. If it's always false, then none of the logic runs. So we need to be somewhere in the middle, which is contingent. And that means that it must return true or false for the condition nulls to work with the logic that is provided. And with these different types of conditionals, if you have a very specific case, such as if you are looping through a bunch of numbers and seeing which one is even as well as is the number 2, you need to put that at the very top of the condition. The reason being is that if you put it at the very bottom, it might potentially hit all the other ones and not even reach the one that is intended. So if it's more specific, if you need like an AND operator or operator, then most cases you would put that to the top. That way it will catch it to be the right kind of logic. So let's go into our first conditional, and that is the famous if-else. With this if-else, there's either if or else if, or just a if or maybe a if-else, but there's a combination of these in all of your conditional logic. For example, if we take a look at how it's set up, we have different types of conditions with these if and these else ifs here. So the first one is always an if. Your first condition will always be an if. And if you have more conditions after that, then you need an else if afterwards. And in some languages, it may look like this. It may be a different type of lettering or a different type of word with it. But in some cases, it will always mean else if, like so. And as you can see here, we also have an else. What this else statement is what will happen if none of these conditions are met. So if none of these conditions are met, then it will run the else. But if one of these do met, then it will run the logic inside of the condition that is met. But let's go through this. We'll go through it one by one and we'll see what's going on with this logic. So here we have a comparison. So when we are comparing, we're comparing the number And here, that might be a new symbol for some of you. This percent sign that you have here, that's called a modulus. Essentially what a modulus is a modulus, you're able to divide the left to the right and it will return some sort of a remainder. And what we're saying here is that if the remainder of this calculation is equals to 0, that means we run this logic of printing out fizz. And very similar thing of what we have in this condition here. If it's divisible by 5, or if the remainder divided by 5 is equals to 0 by both value and type, then we print out buzz. So that's essentially the conditions that we have for these if-elses here. And if the condition is met, then it will do the logic that is right after it. If it's not, then we will go on to the next condition until we reach the very end. And in our last condition here is that we're using the AND operator here. And you can see that if the number is both divisible by 3 and divisible by 5, we will print out fizzbuzz. So this is a really good way of finding divisibility is with the modulus sign. And this is a very famous brain teaser called fizzbuzz. So if a number is divisible by 3, you print out fizz. If the number is divisible by 5, you print out buzz. If it's divisible by 3 and 5, you'll print out fizzbuzz, or else you'll put out some sort of the error or a number. So this is one way you can do that. But let's try to plug in numbers of what num can represent, and we can see how we can run the logic. So if we print out, let's say num is 1, we see our first condition here, 1 divided by 3. Since that's not a clean division, that won't equal 0. Same thing with the 5, so it'll move on to this condition here. So then it'll go on to this condition and see if the 1 is divisible by 5, and in this case it's not. And it sees here on the next case if it's divisible by 3 and if it's divisible by 5, and it's not, so it skips the condition here. Then finally, since it didn't meet any of the conditions, it will hit this else, and this is where it will print out error. So let's try this with another number. Let's try 3. So with 3, we have our first condition, 3. When we modulus it by 3, when we divide by 3, there's 0 remainder. So this logic will return true. So since this condition is true and the condition is met, then it will print out fizz and it will stop there. So we plug in a 3 for num, it will print out fizz. But what about if we put in num as 5? Then it will go to this first one. It will see that it's not divisible by 3. But over here, you can see that it does meet the condition because num is divisible by 5 because we are plugging in 5 in. So in this case, we print out buzz. But there is a problem with how we written this because of one specific use case or multiple use case, and it's this one here. So let's say we have num to be 15. So since 15, if you divided 15 by 3, you actually get no remainders. So if that's the case, then if we plug in num for 3, no remainders, this is true. So that means they will print out fizz. But in actuality, it's also divisible by 5 as well because 3 times 5 equals 15. So since we weren't specific enough, it will always go to the first condition that's met. If we put 15 as num, it will print out fizz, even though it should print out fizzbuzz. So to help this out a little bit, we need to put our specific case at the top. So with the specific case at the top, it catches those special cases of 15, and it sees that 15 is divisible by 3, as well as divisible by 5, then it will print out fizzbuzz. So when you do write your logic, make sure you have your most specific case at the very top. And you can kind of tell if it uses and or if it's a very specific case, then you would put it at the top. So this is actually a better solution for the fizzbuzz brain teaser, is having this at the top and everything else as an else if. So that's how we would do an else if. Every single one of these examples going forward will do a very similar thing, but you'll kind of see a pattern between them and also see how they work. So let's see what the next one is with the case statement. So with the case statement, and sometimes you can see this as a switch too, and we'll go over how one compares to the other. That's just depending on the language. It doesn't mean anything different. It's just another way of doing the exact same thing, and you'll start to see a lot of those inside of the coding discourse. So with the case statement, it works the exact same way as the if else. It's just written in a different way. So the case itself is what you are comparing it to. So you are comparing the num. So the number is what you're comparing. And then for each of these conditions, it will be symbolized by the when keyword here. So when number is divisible by 3 or 5, it will print out fizzbuzz. When it's divisible by 3, when it's divisible by 5, etc. So each of these are the individual conditional cases. So that's how a case statement works. And in here, this is how the default or the else will look like inside of a case statement. Again, this works the exact same way as the previous one. It's just written in a different way. So then let's go ahead and talk about a switch as well as a case. And also we'll talk about breaks here. Because if you kind of look into what a case statement does, is that when it hits a certain condition, it will always continue on until the next condition, until all of them are checked. Even though if we put 15 as num, what it will do is that it will meet this condition, fizzbuzz. It will also meet this condition, fizz. And it will also meet this condition, buzz. And in most cases, you actually don't want that. What you want instead is that when you hit a condition, you should stop the comparison or the conditional. The condition is already met. So that's why you would need something a little bit more with that, and those are break statements. So with this, a case and a switch, the only thing different is the words. This might say switch, and then those are different cases. Or it might be something different or similar with that. So you may have to look it up in the language that you are using. And it might use default instead of else. It just means the exact same thing as an else. But essentially what a break does is those are one of our keywords that we can use inside of conditionals. And when a condition is met, when it reaches this break here, what it will do is it will break out of the execution. So once this condition is met, it will break out of the comparison. Then you can continue on as follows. It doesn't go on from the next condition to next condition. It will actually stop here at each of these lines if a condition is met and then break out of the conditional. And that's actually what we want. So when you are building a case or a switch statement, make sure that you have breaks or returns or something to stop the conditions when you are writing them or when a condition is met. So the next one is a ternary. And at first, when I heard of ternaries, they were a little bit hard to look at. So this is what a ternary is. And as you can see here, it's just mostly symbols, and that might be a little bit hard to look at. I'm going to bring a different conditional for you to see just so you can understand it more. So essentially what the ternary is essentially like a if-else statement, but only in a single line. So if you have a if-else and you only have one thing that you need to do right after the if-else, like let's say you're just printing something towards the end, and you're not doing any sort of other crazy things like another conditional or calling a function or any of that, then you can do a ternary. So those are the cases where you would do a ternary if it's able to be a if else, and also if you're doing one thing after the condition is met or when it's not met. So how this works is that since it is a if else, then let's take a look at this logic. If the name is equal to the string of Bob, then we'll print hello. Else print you're not Bob. So that's the condition that we have with this conditional, is that if we check the name equals to Bob, then we will print out hello here. So how that is written in the ternary operator is that we need to put our condition here of name equals to Bob. If it's true, it will print hello, else it will print out you're not Bob. So it will be signified with the symbols here instead of the actual word here. And we'll see how that works in the next slide. How it works is that the first part, no matter what it is always the condition that you're trying to have. So that is where you will put your condition. and it's always followed by a question mark. And when you're doing a question mark, what goes after it is what will happen if the condition is met. So that is like the if it's met. It's also followed by the little 2 dots here, or the colon. And that is what you would do with the else towards the end here. So with that, you just need the question mark and the colon, but what goes in between them, that's what is more important. It's the condition, what happens if it's met, and the else at the end here. So going back to this, we can see that the condition is name of Bob. If it is met, then we'll print hello, very similar to what we did above. Else, we print you're not Bob, just like so. And that's the ternary operator. If you're still confused, go ahead and play around with this a little bit more and you'll start to see a pattern between an if-else and a ternary. And in most cases, just to clean up your code, you might transition them into a ternary later on as well. So you'll see this syntax and this way of doing conditionals a lot later. Now let's talk about the other keywords, and that is the next and continue. With the next and continue, it goes to the next iteration once it hits that keyword of next or continue. And again, these are program based. Sometimes they're called next, sometimes they're called continue. They actually work the exact same way. So whatever languages it is, these two terms are the exact same thing, but you may have to look which one you would use depending on the language. So if we go into our logic here, if we're comparing the name, so if name equals Bob, else if name equals Jill, else if name equals Alex, then we will print out certain things. And if we go next here, it will go on to the next execution, meaning that it will go on and continue the logic that's going on, such as if we actually put the next here inside of this conditional, it will go on to the next one as well. That kind of works very similar to a case statement. So a case statement may work better if you're doing a next at every single condition, or if you just need it for one or two, then you can use it the next or continue keyword. So these are really good for the next execution or to continue on the comparison if you need it. And that's with next and continue keyword. Finally, we'll go into the switch, and we talked about this a little bit before with the case statement. And again, it's just another way of writing a conditional. So with this, it just uses different wording, right? Instead of, let me compare both of them together. So instead of case and when and else, you have switch, case, and default. So a little bit different terms there. They just work the exact same way. So that's pretty much what a switch statement is. And again, with the switch versus a case statement, that does depend on your language. So it also works the same as the if-else statement, like so. So you can use any of these for your conditionals. So just to wrap up, here are all the conditionals that you would be able to see and the most ones that you are going to use. We didn't go over unless as well as begin and rescue. Unless actually works different than how these other ones are. They actually work a little bit backwards of unless this condition is true, then run the logic. So you can actually achieve the same thing by negating your if-else statement, meaning that instead of saying if name equals Bob, you should say not equals to Bob. And that is pretty much like an unless. So most people, they would actually negate it or kind of change the logic around inside of your if-else instead of using unless. So that's why we didn't go into unless. And then with the begin and rescue, they're a little bit more complex because they're not really conditionals. They just run different logic depending on a time. So when you are beginning, you're beginning to start on a individual logic until you get some sort of error, until a condition is not being met, then it will do a rescue. So this is what you would do during the rescue. And then the else is if it doesn't do either of those, that's what you are doing there. So begin and rescue, you get to see that a lot inside of other languages, but I rarely see them used in a real project unless they're dealing with error handling, things like that. But in most cases, you would use if, else's, or ternary just to clean that up. And we also have keywords here of next, break, and continue, which each of these you can pair them off with your conditionals depending on what the condition is. You can go to the next iteration with next and continue, or you can break out of the conditional with the keyword break here. And that's essentially it for conditionals here. So conditionals are really good for if you need to check on some sort of criteria or some sort of conditions that needs to be met. And that's where you would use some of these items here. But if you're still confused about any of them, I would try them out. Like try to word it out like if something, then something, else if something, then something. I would try to mentally and verbally sound it out to walk things through with these conditionals here. And don't worry about all of them. You don't need to memorize all of them because there's actually a little bit more ways that you can do these things. These are just the most common ones. I would just memorize the ones that you use the most because they all essentially work the same way. And that is it with conditionals. If you have any questions, feel free to leave a comment below, and I'll see you in the next video. See ya.